Hey students, this is Mrs. Tran-Bloom. Now this is section 3.3, features of the functions, okay? Now there's a lot of vocabulary, so what you might want to do is press pause and then write down the definition as we go along, okay? 3.3 says, analyzing a graph means looking at and describing the characteristics with numbers or number phrases. We describe these as key characteristics with mathematical notation or math language. Definition number 1, vertex. Usually we use it on a parabola or an absolute value function. So a parabola either opens upward or downward. Now, an absolute value function, which you will study later, is going to be a V that's going to open upward or a V that can open downward like a parabola, but it's not a U shape, it is a V shape. Now the vertex is either the highest or the lowest point on the graph, and where the parabola or the absolute value function crosses its axis of symmetry, okay? So now the second definition is axis of symmetry. What is an axis of symmetry? Now in a parabola, an axis of symmetry is going to be a line that cuts it directly in half. So that means the left and the right will be exactly the same. Similarly to if we were to have an upside down parabola. It's going to be a line, so that means it will be an equation, okay? If we were to have an absolute value function, there's a line that also bisects it directly in the middle, so that means the left and the right would be exactly the same. So axis of symmetry is a line that divides the graph into two equal parts or two halves. Rate of change is very fancy for the word slope, okay? It is a constant number describing the change in y divided by the change in x. As you guys know already, the change in y is y2 minus y1 and divided by x2 minus x1. That's why y2 minus 1 is called the change in y, x2 minus x1 is the change in x. So again, rate of change is very fancy for the word slope. Now, only a linear and an absolute value function would have the rate of change. X-intercept is the point, or sometimes later we will study functions that would have multiple x-intercepts where the graph crosses the x-axis. Y-intercept is the point or points where the graph crosses the y-axis. We study a little bit about the domain. The domain is a set of all possible inputs. Inputs is the same as x values, okay, for the graph. Range is a set of all possible outputs, and outputs is the same for all y values. Function is a relation, usually a graph or an equation where each x input has exactly one output. So what that means, guys, so let me give you some example. A parabola would be a function, okay? Because what that means is, hey, whatever, let me just kind of make this, whatever x we plug in, so let's say when x is 1 or x is 2, you would get one y value for each x that we plug in. Now, if you guys remember, it also passes the vertical line test. A vertical line test meaning that if we draw a vertical line, that means up and down, on the graph itself, it only intersects 1 and 1 point only. Now, what would not be a function? If I were to give you a sideways parabola like this, okay? So this right here, it's not a function because each input, so let's say I'm going to pick like this value of x, has that and that for y, because that x value location has a y up here, let's call it y1, and a y down here. So this is not a function. And again, if we were to use the vertical line test, students, if we were to draw a vertical line test, can you see that it's crossing over that green sideways parabola twice? So that's why it's not a function, okay? So a function would be a parabola. It can be upside down or right side up, a V-shaped graph, so that's an absolute value graph, and then even a cubic graph, okay, like this. Anything that, if we were to make a vertical line test, it would only cross over one time, okay? So any vertical line test that we graph, it can only intersect it one time. One-to-one, it's even more special than the function itself. So to be a one-to-one, so this is really unique. To be a one-to-one, first you have to pass this function test, okay? So it's a function, but not only that it's a function, it has, not only that every input has an output, but every output can only have an input. So we talked about a parabola being a function. It is not a one-to-one. And here's the reason why it's not a one-to-one. So let me make a coordinate plane. It's not a one-to-one because if we were to plug in a y value, let's say somewhere here, okay, it has two x values. Whoa. So that means it's not going to be a one-to-one. It's a function. It's just not a one-to-one function. So if we were to give you a graph, a one-to-one means if we were to draw a horizontal line test. Okay, so horizontal line test must pass. So that means if we were to make a horizontal line test on the graph, it can only pass, or it can only intersect the graph once. But again, it has to pass the function first. So a function, if we were to make a vertical line test, it has to pass the vertical line test, okay? So must pass vertical line test, or vertical line test must pass first. So that's what it needs to be a function. And a horizontal line test, in addition to being a function of one-to-one, also need to pass the horizontal line test. Maximum, this is a very simple definition, students, is where the function or your graph reaches its highest point. So on a parabola or on the absolute value, it might be the vertex. Now the reason I said might be is because, so if we have an upside down parabola, so this would be a maximum, okay? But if we have a right side up parabola, then that would be a minimum, which is the next definition. A minimum is where we have the lowest point, okay? So again, for a V-shaped graph, it can be a vertex, depending on if it's upside down or right side up, okay? X intervals where the function is increasing. So this is really new to us, students. So I want you to pay attention to these last two definitions, okay? In the simplest definition, we are always going to write the intervals, the X intervals for increase and decrease both, okay? Increase and decrease from the smallest x, comma, larger x, okay? Now, how do we know it's increasing? Increasing is when y goes up, but we write the answer using x value. So I know this is always the most difficult definition of all. In decreasing, we still write it the same way. Smallest x value, comma, larger x value. But we know it's decreasing where y goes downward. So for example, let me just give you a quick graph of this parabola. Let's just say, here we go. And let's make that vertex at, let's say 2. Okay, students? So as you can see, on the right side, y goes up. It goes up until this very, very high point called the maximum point. Well, that's increasing. So on this side, it's increasing. And how do we write that increasing interval? It's some x value over here, comma, some x value over here. Well, the x ends right here. So 2 is where it stops increasing because that's the max. It can't go any higher than the max. Now, where does this end over here? Kind of like the domain. The negative, sorry, this arrow right here means it goes towards negative infinity. So it increasing from negative infinity all the way to 2, and that's the x value. Now decreasing is when y goes down. Can you guys see that? Hey, every time, think about it, we take a step to the right, y is getting less and less and less. So the right side is decreasing because y is getting lower and lower and lower. But when we write the answer, it's called an interval. I mean, it's some smaller x, comma, larger x, okay? So when we write it, okay, well, it starts at 2. But where does it stop decreasing? Well, this arrow keeps going, right? It keeps going to the right forever. So it's going to go to the right, and we saw that infinity. So decreasing for this example that we just made up is from 2 to infinity. Now increasing is from negative infinity to 2.